Okay, let's move towards question number 6, which says that you have a motif formed by the major arc AB of the circle with radius R and center O. The center O and the major arc AB. So that is the major arc AB, right? And the minor arc OAB also with the radius R, but with the center C. So OAB is the minor arc, right? And with the center C and the radius R. Okay. The point C lies in the circle with the center O, given that angle ACB is k radians. So we know that angle ACB is k radians. Okay, state the value of the fraction k. Okay. So it's a kind of a tricky one to to see and to investigate and to reach the conclusion. But the thing you have to find out here is that this angle is the angle at the circle, at the center, right? And this angle, it's the angle at the circumference, and they're starting from the same both points, right? So you must have learned the circle property that the angle at the center, it's double the angle at the circumference, right? It's kind of weird to see it in this shape, but regardless, we have to apply this property. So we know that as the angle at the center is double the angle at the circumference, so this is the angle at the circumference and this is the angle at the center. So we know that it would be double, right? So we can say that this angle is 2k pi, right? And we know that these opposite angles would be equal, right? So I can say that this would be basically this angle, right? Would be like the angle of the whole revolution is 2 pi or 360. So I can say 2 pi minus uh 2 pi minus this 2k pi should give me k pi, right? Because I know that this is k pi. So let's figure out the value of k from here. So we can say that so yeah, let's take 2 pi common here. 1 minus k is equal to k pi. Let's cancels. So we would have okay, so 2 minus 2k is equal to k, right? Let's the k can go on that side. So that would become 3k is equal to 2. Now we can make k the subject, which would be 2 over 3. So that is our answer, okay? That is for 1 mark, and you have to really think it through the 1 mark, but it's fine if you weren't able to figure it out, right? I mean, because it's only 1 mark, so you would lose 1 mark technically. Okay, state the parameter of the shaded motif in terms of pi and r. So we have to state, so it means you don't have to calculate anything, right? So the parameter of the shaded motif in terms of pi and r, right? Right. So the thing that you have to figure out here is also that, okay, so if I say that this would be equal to basically this, okay, we had to figure out that this arc length would be equal to this, right? Because this is the center, right? This is a center. So I can say that this is the radius and this would be the radius too, right? Or, I just found another way of doing this. That would be much easier actually. I just found another way of doing it. Okay, sorry. Yeah, so that another way is actually a lot easier. Okay, so I know that this is R, this is R. So this would also be R, right? This is the radius. So I can say that this is a 60-degree angle, right? It's an equilateral triangle, and in an equilateral triangle, this angle is gonna be 1 over 3 pi, which is 60 degree. And I can say the same for this side too. So 1 over 3 pi times 2, that would be 2 over 3 pi. So k would be 2 over 3. Easier. That's like a easier method of doing this. Okay, I'll just write this here. You don't have to, yeah. These are the two methods to do the same thing. You would get the same answer, but I think the second method I did was an easier method. Okay. So from doing this method, you're also getting the same answer. So this one, okay? Right. So yeah, so for part B, you have to find the parameter of the shaded region. So can I say that this is basically equal to this, right? And if I say that I have to calculate the parameter of the shaded region, that would be essentially saying that I can figure out this, and that is the same as the parameter of the shaded region because I know that this part is equal to this part, right? So what would be the parameter of the circle, which is 2 pi r, right? That is the formula for it. So that's just 2 pi r. Okay, so for part C, find the area of the shaded motif, giving your answer in terms of pi r and under root 3. That's a 5 marks. Okay, so we have to find the shaded area. So for the shaded area, what we can do is first we can find the major sector, which is this. Okay, so center. All right, so this is one of our major sector that we have. And we know that this as this angle is 2 over 3 pi. So that angle would be 2 pi minus 2 over 3. So 2 minus 2 over 3, which is 4 over 3. So this is 4 over 3 pi, right? And we know that this has also, the radius of r, right? So we can figure out the whole thing and then, okay. So then we would have to eliminate these two, right? So how can we do that? Let's see. So we have this sector right here. Yeah, we have the sector, and then from it we can subtract this. Yeah, so we can then so we have this sector, and then what we can do is we can subtract the area of these two triangles, this one and this one. So if we subtract these two triangles, you would only get this part, right? This green part I'm shading, that would be only be left after we subtract the area of the two triangles from the sector. And after we have found these two green areas, we can subtract these two green areas from the larger area of the larger sector, and then we would have our answer. So I know it would seem a little complicated now, but let's do it so we can have the clearer idea of how this works. So okay, let's first find the area of the major sector, which is this sector. So major arc AB with the center O. So major arc AB with the center O. So this is what we're talking about. Let me just draw it nicely. So this, and this is the major arc. So if we figure out this area of the sector, we would get this whole thing, okay? This whole thing. So just keep in mind that with what we're doing now, we are calculating this whole green area. So that is half r squared theta to calculate the area of the sector. So half r squared, r is r here, and theta. So we that was 4 over 3 pi, right? Because it would be double of yeah, you can say that because it lies in the center, so it would be double of this, right? Which lies on the circumference, or you can also do this by subtracting this by 2 pi. You'd get the same answer regardless. So yeah, so theta is 4 over 3 pi, right? Just this is your area of this green part, right? This green part, I'll just shade it green so you know. Now, okay, now what we have to do, let's calculate this area of this sector, which is this sector. Okay, so this sector we have to calculate now. So let's calculate the area of this sector. So this would the formula would remain the same, half r squared, and theta in this case would be this, which is 2 over 3 pi. So 2 over 3 pi, right? That is our red area. Now, from that red area, we can figure out the area of these two triangles. right? And then we can subtract these area of these two triangles. So how would I draw these two triangles? As you can see, we have this first triangle, which is an equilateral triangle. So we can do, so we know that this is 60, right? Each of the angles is 1 over 3 pi. So I can do half AB sine C, half times A is R, B is R, and then sine 1 over 3 pi. And as I know there are two triangles, so I can multiply this by 2. So 2 cancels out, and then I would be left with, okay, make this a little smaller. I would be left with R squared and then sine 1 over 3 pi if I do that in my calculator, and make sure your calculator is in the radian mode, okay? So sine 1 over 3 pi, which is under root 3 over 2, right? So these are the area of our two triangles. So what we have to do now is, if I have this whole area of the sector, right? And if I subtract the area of the triangle, I would only be left with the area of these two regions. Okay, let me just make this a little cleaner. So I have to calculate these area of these two little regions here, and I can do that by subtracting the area of these two triangles from the area of the whole sector. I know that the area of the whole sector is half R squared 2 over 3 pi, and then I can subtract this of like by the area of the triangles, which is under root 3 over 2 R squared. Right, let's take R squared common, and then I would be left with half. So if I multiply these two, that would be 2 over 6 pi minus under root 3 over 2. Okay, so that is our area of these little regions, right? And now from this area of the whole sector, which includes these little areas, which these yellow areas. So from this area of the whole sector, I can minus these two little areas and I will get the shaded region. Okay, so I have the whole area of the sector as half R squared 4 over 3 pi. And then from it, I can subtract this, right? From it, I can subtract this area which we calculated, which is R squared. And then inside the bracket, we have these. Okay. Okay. Let's simplify it. So let's take R squared common, then 4 over 6 pi minus 2 over 6 pi. And then plus, I guess, plus under root 3 over 2. Okay. So that's it, and then I'll just make it a smaller. Okay. So let's simplify it further. So 4 over 6 minus 2 over 6 is going to be 2 over 6 pi. 2 over 6 pi, or yeah, 2 over 6 pi, or you could say 1 over 3 pi, right? It's the same thing. Plus under root 3 over 2. So that's it. That's our final answer, and that is correct. Okay. That is our final answer. I'll just copy my final answer and paste it over this. So this 5 marks. That's what you had to do for the 5 marks, and that's it. That's a correct answer, okay? That's your shaded region.